Hello and welcome to the Let's Talk Azure podcast with your hosts Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Office 365 focused IT security professionals. Each episode, we talk about a specific topic in the space. This week, it's episode 5 of season 3. We're going to have a chat around confidential computing in Azure. If you have a strong focus on confidentiality and trust, or you operate in a regulated industry, confidential computing aims to provide zero trust principles to your virtual machines so you can protect yourself against advanced threats and collaborate with third parties securely. Hey, Alan, how are you doing?
Hey, Sam. I'm not doing too bad. How are you?
Yeah, good, thank you. Season 3, episode 5 already. It's flying through now, which is good. We seem to be having good feedback on the podcast as well, and good listen numbers as we've come back.
Yeah, well, if we're aiming for 20 episodes this season, we're a quarter of the way through. If you think
Yeah,
about it
that is
that way.
actually, yeah, definitely. Yeah, I hadn't thought about it like that, to be totally honest with you. Yeah, because we generally tend to do around 20 episode chunks, don't we? Of seasons to get a couple of seasons in a year. So yeah, it's flying through. Right, let's dive into this topic. I'm going to be taking us through confidential computing solutions in Azure. It's not an area that we have deployed into production yet, but it's an area that I have been sort of investigating over the past few months because what I'm trying to do is to provide more confidential and secure options to our customers, and to really understand how we can take especially IaaS, infrastructure as a service, resources to the next level of protection.
Yeah, I think some of this we may have touched without knowing it. We've actually done
Definitely,
it recently.
yes, without a doubt. Yeah, 100%.
Okay, so let's get into this then. So, Sam, can you give us an overview of confidential computing for us?
Okay, so if we think about some of the more common protections that we've got in place in the cloud, we've traditionally thought about encryption at rest. Making sure that when we store our data, it's encrypted, so that unauthorized access, should anybody have access to, say, um, that disk, or any other area inside of Azure that can be encrypted, we've got some level of protection in there, and also in some ways, some level of protection, within Azure as well. Um, and then we also talk about encryption in transit. So we're talking about TLS, encryption across the wire, and making sure that our flows of data, in and out of Azure, and also in and out of different services inside of Azure, is fully encrypted. Now, a lot of the regulatory compliance frameworks, really leverage encryption at rest, encryption in transit. But one area that is less commonly um, thought about, from my perspective at least, is when data is in use. So it's great that when we communicate in and out of, say, a virtual machine, things are encrypted, and that disk is encrypted as well. But what happens when we're actually running our applications and workloads and our data inside the virtual machine? So things like the memory that we're using, and really understanding how we can protect ourselves against different threats inside of that environment. If you're familiar with zero trust principles, mainly in like identity and access security, it's effectively applying zero trust principles, but to infrastructure and um, application environments. What we're aiming to say is, can we trust the hypervisor that we are running on? Can we trust the Azure platform that we are running on? Now we obviously have an inherent level of trust with Microsoft running our services. But in some industries, some regulated industries, may say that you cannot trust Microsoft, even if you yourself and your organization do entrust Microsoft with your data. We're not talking about uptime and reliability. We're actually talking about data confidentiality and protections, on that data. So some of these principles for some organizations are an absolute, essential part of their world and their workloads.
Yeah, it's really interesting because you talked about zero trust as the way that I've seen it. At least it's been access to services, things like that, like you said, and about the device being trusted and things like that. So thinking of it from a hardware, almost a hardware perspective in some form, is another viewpoint of that.
Yeah, because if you think about zero trust in terms of somebody's endpoint, right? That endpoint is in the control of somebody that you trust. We implicitly trust the user that's got access to that machine, and we can put protections in place so that user can or can't do certain things on that device. Um, but what you know, the custodians of our IaaS virtual machines, is Microsoft and Azure. And from my perspective, I've got no reason to distrust them. But into when you're talking about absolute security and guarantees of data confidentiality, um, you do need sometimes you do need technical interventions to make sure and actual confirmations that nobody else can get access to, not even if they are, but absolutely that can't happen. And Azure gives us three different levels to that confidential computing stack.
Okay, so you mentioned three levels. Can you give us an overview of those three levels?
Okay, so I'm going to start just with virtual machines, infrastructure as a service. There is a PaaS offering as well, which I'll talk about. I won't talk about as in depth as virtual machines, because I think we could do a whole other episode on that as well. Okay, so level one is what they refer to as trusted launch. Trusted launch is very similar. If you've heard of the trusted platform modules, TPMs, secure boot. Um, this is this is effectively the exact same technologies that are being utilized here. So when you create a virtual machine inside of Azure, there's a drop down box which is called security type, and I believe you can just have, I think it's called standard is picked by default. And what you can then do is you can change that over to trusted launch virtual machines. That's going to enforce secure boot. It's going to also enable a virtual TPM for you as well. What we're trying to protect against here with this is the boot sequence. So from boot to operating system loaded, that the integrity of that boot sequence is maintained. So we're protecting against firmware rootkits, boot kits, driver rootkits, and kernel rootkits. So anything that could be injected as that boot sequence happens. Um, and I think is in what is important to note about this is this is very, you may already be using this, right? You may have already enabled this, and in terms of an impact in for your virtual machine, it's very low impact. You do have a reduction in the number of marketplace images that you can pick from, because they have to be secure boot enabled, and there are some other limitations that I'll also talk about as well. But what we're ensuring is that we're ensuring that that boot sequence is protected. Um, and what we can also layer on top of that is we can also layer a Defender for Cloud on that. And what Defender for Cloud can do is it can give you trusted launch attestation. So what attestation is doing is it's checking to make sure those enhanced security, features are if they are enabled, and performs attestation to make sure that they are actually being enforced and the integrity of um, those solutions is being maintained. So you can effectively have layered on top, you can have Defender for Cloud constantly checking to make sure that the integrity of secure boots and your TPM is being maintained. Just to talk about some of the limitations of it, Azure Site Recovery is currently not supported with Trusted Launch. Um, the the There is no ability to do nested virtualization with it either. Um, there are some that can do nested virtualization, but there are only certain SKUs. But the majority of SKUs can't do that. Um, it is available in all regions, and you are going to have a reduction in different types of VM sizes. So A series machines aren't supported, but the main ones are B series, DC, DV4, like the the more, I would say, like standard production ready instances are going to be available, and you are going to have a reduced operating system support. Obviously, great support across Windows 10, Windows 11, Windows Server, and in terms of Linux and Debian, we've got Ubuntu, Red Hat, Debian, CentOS, Oracle Linux, and that sort of thing.
Okay, that's quite interesting, because then when we were talking about AVD the other day, in effect, because we're using Windows 11 multi-session and Windows 11 requires TPM, we'd enabled that. So in effect, without sort of knowing, we'd enabled this trusted launch side of things. So it's starting to sort of standardize against the endpoints as well, around Windows 11 requiring the TPM and secure boot and things like that, and just bringing it to the to Azure.
Yeah, exactly. Yeah, and I think if you are already, to me, the very small number of limitations that trusted launch brings to you, um, there's massive upside there. And like you say, certain operating systems now have the standard that they require these provisions to be in place. We've talked about you know uh, well, all the versions of Windows 11, I believe requires TPM. And I assume Windows 11 also requires secure boot, doesn't it? It must do.
Correct.
I'm
Yep.
guessing so. Yeah. So if we take those learnings from endpoints, and best practice from in modern endpoints, we're now applying those into Azure 100%. Okay, so that's sort of the first level, and that is what we would term as a lift and shift, a change. Your application doesn't have to change at all. Your operating system, you take the provider that you trust, the hypervisor, Azure, and you trust the administrators that are in and the users of that operating system completely. But it does give you some level of protection, and also you can do attestation to verify the integrity of what is going on there. Level two is takes that a step further. So we have confidential virtual machines. Confidential virtual machines utilize AMD processors, and the technology is called SEV and SNP technologies within inside of AMD CPUs. What that is doing is providing memory integrity and encryption of memory all the way down to the CPU. So it's the data in memory and inside the processor state that is fully protected. What this is doing for you is it's giving you protection from Azure. So, Azure platform, Azure administrators, and the hypervisor that is running your virtual machine. So, if we think of the layers of a virtualized host, you've got the underlying hardware and firmware that is controlled by AMD, Intel, etc. Then you have the BIOS. Then you have device drivers. Then you have the hypervisor, cloud management software, and then you have your virtual machine, layered in on top of that. So confidential, virtual machines is giving us, those four middle layers: the BIOS, the device drivers, the hypervisor, cloud management software. All of that doesn't have any access to processor data state or memory data state either. So we've got a direct, a protected link straight from the virtual machine down to the AMD hardware as well. So you would have to distrust, the actual the hardware that you're running on at that point, because your virtual machine has a protected way to communicate with it.
So so if we're talking about non-cloud on-premise, we would trust those layers because we are, the organization owns that and looks after it. So there's a level of trust there where within Azure, whilst there is a level of trust, it's not your organization like owning it, and you don't know what protections are in place, I guess.
Well, yeah, I was thinking about this, and because it's my assumption is, and I haven't looked this up, is that you could also run this on prem, right? Because it's AMD tech, right? And I assume it's Hyper V and all of that, doing the glue in between. I believe it's actually because there's separate images, right? So I think it's actually the operating system, right? So I was thinking, sort of thinking the other day about, if you did have if I was an application owner, right, inside an organization, would it also be correct to apply those principles in, because traditionally on prem, yes, you would control, you can physically control the infrastructure, and you also, there's people inside your organization that also control those various layers, right, with
Hmm.
inside of it.
Yep.
So yeah, I would completely agree with you. Traditionally, it's inside your fortress. You trust everybody inside your fortress. But then I sort of applied sort of, insider risk thinking, and I was just kind of like, well, if I'm an application owner, so one of the examples that they use is like health care data. So if you take your health records, that is obviously highly sensitive, personal data to you, right? Versus maybe other auxiliary sort of systems like appointment booking and things like that, right? So this is a convoluted example because it's probably not like this. There's probably loads of confidential information in appointment booking, but let's just pretend that like appointment booking is like booking. Let's say you're booking your flu jab, right, at your doctor's, right, and let's say you say I'd like a flu jab and I would like to come in on X, Y, and Z date, for my flu jab. There might not be inherent, really highly confidential data in one part of, that organization, but in another part of the organization, you might have really, highly confidential information. So if you said like, if you had like your groups of users and you said like the doctors are the only people that can, the doctors and the nurses are the only people that can, view patient records, but the scheduling assistant can only see, the appointment, booking slots that have no, patient data inside of them. Um, so I could imagine that even in like an on-prem environment, you might say, okay, well, we want to protect that highly confidential, health data against the infrastructure admins, because even though yes, you're the infrastructure admins, but you should never ever be able to have access to that data. That even if you are, quotes, global administrator, that doesn't give you the right to be able to view that data and to also verify that you don't have access to that data. So I as I was researching, I saw many different like use cases for these types of technologies. So I think more increasingly that is actually being applied on prem, as well for those types of protections.
Yeah, I guess think about it that way as well, is whilst you do have the insider risk of an employee, I guess you got the other potential of a bad actor being in your environment and compromising that device
Yeah,
and then accessing that data without accessing the VM sort of thing. So there is
yeah,
that as well.
you are putting layers in terms of like lateral movement inside the organization, right? Hop to the crown jewels, so to speak. So yeah, it did this whole and this is why I I sort of decided to do an episode on it, because it really sort of sounds a bit cheesy, but it really challenged my thinking in terms of how these different layers of security really should work for different types of workloads, because we see it more in identity and access, that sort of world, right? But this is and from the endpoint side, but this is actually like data that's being used, which is also important to protect. um So this layers on top of trusted launch. So you've still got your secure boot, you've got your TPM, so you've got your boot into operating system. So you are also controlling that as well. That um, Now the numbers of images are going to reduce down as well, because I believe there has to be changes to the images to actually support this AMD technology and to do that link between the virtual machine and the CPU. But currently I'm seeing 9 images, but they do cover Windows Server, I think 2019 and 22, Windows 11, SQL Server, and Ubuntu as well. So there's, you know, unless you've got a different flavor that you're accustomed to, it's pretty well supported. Again, this is a lift and shift technology. You don't have to change your application that's running. This is an infrastructure change and a SKU change. um but what it still doesn't do is it still doesn't give you um it still doesn't give you um protection inside the operating system. So we're still talking about, so inside the operating system, we are still this is our fortress is inside the VM. We still implicitly trust our like admins and people that are working inside of those systems. Um, it's worth calling out as well that there are some limitations with this system as well. Um, we are we are looking at no accelerated network support. So if you require that, that's going to be an issue for you. Also, nested virtualization is also not supported in this scenario as well. There's just a few, but if you have looked at confidential VMs in the past, the limitations have really dropped. When I was investigating, it looks like when previously when it was released and different versions for hardware, there were a lot more actual limitations there. So things have come a long way inside of its journey. That's for sure.
Yeah, I guess there's been some more processors that support it and things like that, and Microsoft have improved or included more SKUs into the data centers.
Yeah, yeah, exactly. And just to make you aware as well, those confidential VMs undergo attestation as part of their boot phase. So it's again, Azure is checking to make sure that those virtual machines are booting into the correct modes to give you that level of protection. And there's a guest attestation. I think it's an extension that you install that actually runs as part of that. You can't also um, switch a non-confidential VM to a confidential VM. You will have to rebuild your virtual machines, but not your applications.
And that's because, like you said, it's to do with the operating system. But part of it is part of the operating system as well as the SKU that it sits on.
Exactly. Yeah. Okay, and the third level, which is the highest tinfoil hat mode that you can possibly get to, which I think is actually pretty cool. This mode is secure enclaves with SDX. So SDX is a technology created by Intel. So there are only Intel SKUs, um, and what is interested about this is you can run these SKUs without trusted launch. Because what's happening when we're using secure enclaves is we are effectively running the code and the data for our application in a secure enclave directly connected to the CPU. So if you imagine you've got an application running on a server, that is obviously using the processor to do cycles of data processing, loading data in and out of the CPU rapidly to do computations and calculations. And then you've also got the data that's sitting in the memory for that as well. So what a secure enclave allows you to do is run that code and that data inside a protected sandbox with a direct connection to the CPU, and that is each app independently. So what's great about this is you theoretically don't, in terms of the data that's running, on these workloads, you don't even have to trust the users and the admins on those machines, because even inside of the virtual machine, you do not have access to the memory and the data that's running through being processed on the CPU. So, but so so effectively, you could theoretically run this without any trusted launch, because the it doesn't inherently trust the operating system in which it's being run. So 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 you don't have to enable secure boot. You theoretically don't have to enable secure boot in TPM unless your operating system requires that. So your application is going directly to the CPU to run. You the obviously it could be quite an obvious downside is that your app has to be modified to support this technology. There are some initiatives and SDKs around that. So there's Open Enclave, the Ego SDK. Intel have their own SDK as well, and there's also the confidential computing framework as well. Just give me one sec. I'm just going to.
So, so this is kind of bringing in the, if I think about from an endpoint perspective, this is bringing in the starting to bring in some of the similar things around like credential guard, where that's being isolated from the operating system so that you can't scrape credentials from it. And then I guess an up from that is the application guard, where you can put Edge, Chrome, and things like that into a container to stop you from leaking data. This is going to the next level of having an application that you run on a server and having that isolated from the operating system, as well as the hardware in effect, or it's in effect, and then so that it's anything running in there can't be compromised or
Yeah, so
pulled.
if you imagine a whole process can be completely isolated, from anything else that's running. So the inputs and outputs could obviously be, sniffed from if you're writing to, a disk, or you're,
Hmm.
sending, your outputs, to and from the machine. But the actual underlying sort of intellectual property of that application is protected. And one of the big sort of selling points of this is that you can have intellectual property collaboration between two parties. So let's say I'm organization A and Alan, you're organization B. Me, organization A, I create a machine learning model and a black box that, draws pictures or completes code for you or whatever it is. But let's say you want, organization B wants to license that from me and run it on their own hardware. How can I trust that you're not effectively going to, run my application, inspect my process, look at what's being loaded into memory, and protect against that? Because we've had obfuscation of, of code and of data storage mechanisms for a long time. So there's good protection there. But when you're actually running that process, it's relatively trivial to inspect the memory and to reverse engineer from a memory perspective. So what we could do is we could both agree to use SGX technology to, to protect my intellectual property, but you still get the value of licensing it from me, or running it from me and getting value from it. So when you are running in I'll call it a hostile environment. I'm not saying that organization B is inherently untrustworthy, um but when maybe your business, the value of your business is completely centered around the intellectual property that you have, putting protections in place to make sure that that can theoretically never have any implications to your business is a really powerful tool that you can utilize.
Yeah, I guess it kind of opens, when you're concerned about that sort of things, it's opening up more doors, more ways for that collaboration, getting your product out there to be bought, used, utilized, that sort of thing. So that's really good.
Yeah. Yeah, because you could just put a limitation and say, I only want you to use, DC SKUs inside of Azure because we're going to use Intel SGX. Like, we require Intel XGS XGX to protect against that. So I think it's also worth noting that in the previous versions, in version 2 machines and SKUs, you could only actually support 168 meg of encrypted memory at the highest level. So it was actually quite restrictive in terms of what you could, use into there. But I now believe with version 3 and above, you can go to 256 gig of encrypted memory. So actually, you know, the amount of the workloads that you can actually secure now, are a lot more varied. So this does give you the most confidentiality, you know, um, but it's definitely not lift and shift. You have to, change your applications. I haven't even looked into that process, so I can't even, comment on that. And the only other just point that I just wanted to make around this is there are some limitations. So let me just bring up my list of limitations. So certain things are supported and aren't supported. So nested virtualization again, none of these none of these things like nested virtualization, because you can kind of kind of understand why. And I think the other big one that's important for this one is hyperthreading is not supported either. So which is an interesting take on it, because there's that could limit some performance, because there are only specific SKUs for this one.
I guess that's because in effect hyperthreading is virtualization of the core anyway, isn't it? In effect, so you can't trust that virtualization in theory. I guess. I
Yeah,
guess so.
yeah. I know. I didn't actually have the time to look into the underlying platform limitation, and from what I can tell, SGX is just part of Intel processors. So again, my assumption is this can be run on prem if that's also how you want to slice things up, for complete application isolation. Um, so yeah, so they're the three levels really. So you've got trusted launch, virtual TPM, which some operating systems require now, and also secure boot. Booting integrity. The loading of the operating system. Confidential VMs. If you don't trust Azure, anything in between you and the bare metal, Confidential VMs are a great way to lift and shift your workloads into a confidential environment. And then if you want to go, absolutely to the max, and you require you know, complete um, oversight of those your processes that you're running, SGX is the way to go there, to fully secure. And I just wanted to also quickly talk about the Azure attestation service, which is effectively a service running that Azure runs to verify the integrity of these technologies that you're actually running. So I believe you can verify them inside the virtual machines themselves, but from a management and a reporting perspective, Azure attestation is doing a lot of that heavy lifting for you. So it's making sure as the machines are booted that they're going into the correct states, and the correct, the integrity is being maintained. And then you've got things like Defender for Cloud also reporting back and feeding into your security posture as well. The last area that I just wanted to talk about briefly was platform as a service, because we've just talked about infrastructure as a service. I'm not going to go into this in too much depth because I do think it could be its own episode. But this is where it really comes down to deployment models as well. So, um, effectively, platform as a service in terms of confidential computing is confidential containers in Azure. So what we're seeing here is a enclave aware containers in Azure Kubernetes service. So you can run Azure Kubernetes service and your workloads inside of there in a secure and managed way. Now, organize the containerization of workloads is a conversation and a complexity in itself, right? But some of the benefits of going through that process is really fine grained control of resources, orchestration of resources, and management of them at scale, right? So you effectively chunk up your applications into isolated containers, you manage them, and don't manage the underlying infrastructure. You have your own infrastructure to orchestrate, deploy, and manage those workloads. So if you effectively think like another level on top of the operating system to manage that, and you've got continuous deployment and different things there. And it can also really help if you have different languages and frameworks that you use to build your applications. You can have isolated containers where different product teams can work, and you don't just have to be like a .NET shop or X, Y, and Z, whatever it is that you've got. So Azure does have an offering to make Azure Kubernetes service enclave aware, to give you that full isolated process down to the hardware level. Um, Again, um, I'm not going to talk in too much depth, but one area that I can really help with is also multi-cloud support, because those containers run on top of let's say Kubernetes. It is possible to run multi-cloud workloads with that, so you can have interoperability of where you can run those workloads. If that makes sense, you can get the power of SGX with containerization of those applications and processes, but without the inherent um, downside that you have to invest in wrapping all your applications inside of SGX. But I think I'll do a whole other episode on confidential computer in AKS, because if you don't know Kubernetes and containerization, we have to do a primer on that first to understand, really, I think, to truly do it justice, what's going on there.
Yeah, definitely. It's good that it's been exposed to both sides. I mean, normally, it does, but um, sometimes it normally starts in one area. So it's good that it's now in platform as a service and the IaaS side. So
Yeah, well, I think from my perspective anyway, I previously lived in just the PaaS world, right? I I saw very. I mean, there's loads of it out there, obviously, but I personally saw very little, IaaS, deployments in my time as a software developer, um, and so when you are talking to those regulated, industries, they are um, they are very very hesitant around data storage and data processing, and having the approach to both sides is vitally important, from my perspective.
Yeah, definitely. Okay, so to enable this stuff, what's it cost? Is there another cost to it?
Okay, so um, effectively, you just pick the correct SKUs that support, the SKUs of virtual machines that support this technology. Um, I did do a comparison, and it is comparable to other, virtual machine costs per, ratio of, CPU and memory. The confidential VMs have two SKUs, which are general purpose DCA instances, and then there's ECA, which are memory intensive ones. The enclaves ones only have DC versions. So if it's DC and then a number, then it's Intel. If it's DCA, it's a general purpose AMD for confidential, and if it's ECA, it's a memory intensive for um, AMD. As of recording, there's still no memory intensive versions um, of enclaves with SGX. So there's still a good amount of SKUs in that, but if you do have some specialist workloads, they're not supported. Also, no GPU workloads either in those SKUs. So if you have so a lot of these, a lot of workloads now are accelerated by graphics cards as well, and there is technology that is emerging, if not, ready to go, where they are now doing secure enclaves with between CPU and GPU as well for completely, all the way through those, those controls. There is technology coming through for that, but I'm not seeing that in Azure specifically at the moment.
I was going to say I expect that the reason why they're not there is because the securing part isn't in the GPUs and things like that. So, but as you said, it's coming because it's becoming. It's probably partly because of this, but I expect it's probably more for the gaming industry to stop people manipulating stuff maybe within the games as
Yeah,
well.
I thought it was going to be all machine learning model like acceleration,
Okay.
but I think the GPU side is more for training of machine learning models than it is actually running them. So you know, so once you actually deploy them into prod, you would effectively then just use those models, I believe, through the CPU.
Okay.
So I think that's why. But apparently that is a thing that is going to happen.
Okay. Cool. So we kind of talked about it a little bit, but level 1, 2, and 3, are they easy to set up? I mean, it sounds like level 1 is like it's sort of a no brainer. If you got that SKU, you can just like in effect, a couple of clicks and it's done. You don't have to worry about it.
Yeah, if your image that you want to use is supported, and you can also make your own images from their base images as well, is supported, then I think, personally, I think trusted launch is an absolute no brainer. Because we have user endpoints that have this stuff enabled. Like, it makes very little sense to not have it also in your infrastructure. Level 2 does restrict down the number of images that are there. So there is a potential, but from a setup perspective, you are just clicking through the portal like you would anyway. So it's not really, causing too much, to go on there. Um, and then you've got the guest attestation as well, but it's definitely not complex to set up. I think the complexity comes in the limitations that you're going to see. Um, maybe you want a specific skew of instance or something like that. Maybe you want to use burstable instances. That's not going to happen for you, and things like that. So you're also going to be driven by cost as well, because these are like proper instances you got to pay for. And then SGX obviously is the highest barrier to entry, because you've actually got application changes that you need to make, and you're also then you are limiting yourself to only ever running on though Intel processors that have SGX technology inside of them. you know so you are limiting yourself in terms of the portability of your solution. But my assumption is, if you're the sort of organization that requires the level of confidentiality of SGX, you could probably pay for those instances anyway. So that's my sort of thought process on it. If you're willing to go to that level, then you're probably willing to put the funds in to make sure you're fully secure all the way down.
Okay, so we're saying that in effect, level 1 and level 2 is configuration of the VM as you deploy it, and then it's done. You're in those modes or those scenarios. And then 3 is that choice again, but your software has to support the the technology. So yeah, okay.
Yeah, exactly. And theoretically, you could run level 3 without any of the other protections in place, because you're going app process all the way down to the processor. At that point. So yeah, but from a 1 and 2, from a day-to-day usage perspective, it's just a different skew. There's nothing more to it than that.
Cool.
Okay, so Alan, that's a quick, 47 minutes on confidential computing. I hope I covered it. It's an area that I'm keeping my eye on more closely, because we do have requirements for highly confidential information to be processed and stored. So this is a really good, way of doing that and keeping it in the forefront of our thinking when we're architecting solutions. So yeah, but hopefully we'll follow up with a PaaS, confidential computing. I think we'll just have a AKS, you know, mad fest of AKS episode where we try
is
and talk about that for
is that the
three
name
or
of the
four
episode,
hours.
is it? AKS Madfest.
I don't know, but it's yeah, it's probably going to be a bit of a beast, that one, I must admit. What's the next episode?
So I'm going to go through securing Office with Microsoft Defender for Office. So talking about the capability within Exchange, as well as some of the other places within SharePoint and OneDrive. So might be a short episode, might not be, but we'll see. There's a lot in there. It's growing as always, and it builds that XDR story as well. So
Excellent. So if you've enjoyed this episode, please do consider subscribing if you'd like to listen to more of this sort of content in the future. We have many more topics that we'd like to cover, and your listens and support is what will continue to fuel the podcast going forward.
we also have the ability for you to give us some feedback. Did you enjoy this episode? Disagree with what Sam said? Did we miss anything? Please use the form in the notes for the episode and leave us some feedback. We'd love to hear from you.
Cheers. Thanks, Alan, and thanks everybody for listening. Catch you next week.
Yes, thanks, Sam, for a great episode. And yep, speak to you soon, guys and girls. Bye.